Alright, today's lesson is on circles and central angles. By the end of this lesson, you should be able to identify parts of a circle and find the central angles in a circle. Before we begin, let's discuss some key terms. Over here I have a depiction of a circle. Notice that the center point of the circle, is labeled A, and we would refer to this as circle A. A radius of a circle is a line segment with one endpoint at the center of the circle and the other endpoint on the circle, as I have it depicted in this purple line here. A diameter of a circle is a line segment that runs through the center of the circle and has its endpoints on the circle itself, as I depicted here in this green line. Therefore, the diameter will always be twice the length of the radius. A chord is just a line segment that has both endpoints on the edges of the circle, but it doesn't necessarily have to go through the center of the circle, as I depicted here with this blue line. So once again, this blue line is called a chord. The green line that runs through the center of the circle, that passes through the center of the circle, is called a diameter. And the radius is a line that goes from the center of a circle to the edge of the circle. Alright, so let's identify the radius, diameter, and chord in the following diagram. Alright, so the radius is here. There are in fact three. We can see that, let me get my laser pointer here, that line segment, when I write BD here and I write that line over it means line segment. So the way that I read this is line segment BD. So here's line segment BD, and we can see that line segment BD runs from the edge of the circle to the center of the circle, so it is a radius of the circle. Now when we label a line segment, we have to label it by its endpoints, but the order that we do that does not matter. So although here I've labeled this line segment BD, you could just as easily call it line segment DB, and that would also be correct. So another radius here is line segment ED, because line segment ED runs from the edge of the circle to the center of the circle. But once again, I could call that line segment DE. They are both radiuses of the circle. There's also one more radius in this circle, and that's line segment DC, or line segment CD. It runs from the center of the circle to the edge of the circle. So I'm looking at this picture. Now I'm asked to identify a diameter. So all you're looking for is a line that runs through the center of the circle but has both of its endpoints on the edge of the circle. So the line segment that I see here is line segment BE. Notice that BE runs through the center of the circle, which is D. We could have also called this diameter EB. As long as we label it by its endpoints, then that is a correct way of labeling a line segment. And finally, if I identify a chord, we have the chord AF. We could have also called that chord FA. So take a moment to pause the video and see if you can identify the radius, diameter, and chord in this diagram. Alright, well in this diagram there are in fact three radii. The plural of radius is radii. So we have three radii here. One of them is radius XZ or ZX. Another one is radius ZR or RZ. And another one is radius ZW or WZ. All three of those in this diagram would be referred to as radius of the circle. In this diagram, there's only one diameter depicted, and that's diameter XR or RX. Remember, RX or XR runs through Z, the center of the circle. And this whole circle would be referred to then as circle Z. We label a circle by its center. And finally, the only chord in this diagram is chord YS or SY. So it's just a line segment that connects the edges of a circle but doesn't go through the center. because when it goes through the center, then it has a special name, right? We call that the diameter. All right, so let's have one more practice identifying the radius, diameter, and chord in the following diagram. All right, so let's label the radii. I can see one here. Look, it goes from the edge of the circle, point D here, to point A. All right, so I could label that radius dA or AD. I prefer to label them first by the center of the circle and then the edge. So I'll go ahead and call it radius AD. And I draw the line above it, right, to indicate that it is a line segment. It's part of a line, and the endpoints of this line segment are points A and point D. Another radius of the circle is radius AB, right here. So again, I'm going to go ahead and label that radius AB, and it's a line segment, so I have to draw the line above it. We have another radius. That's not the only one, right? Anything that goes from the center of the circle to the edge is a radius. So here's radius AE. I'm going to label that AE. Here's radius AG. And in this diagram, that's the only radii I see. Let's talk about a diameter of circle A. So remember, a diameter has to run through the center of the circle first and foremost, and then it has to have endpoints, any two endpoints on the edge of the circle. So it has to run through the point A, and have endpoints on the edge of the circle. The only one that does that in this case is radius DE or ED. You could label them either way. So I'm going to call that line segment DE. You could also call it ED. Those are the exact same line segment. And finally, let's label the chords in this diagram. All right, so remember what the definition of a chord is. A chord is a line segment that has the endpoints on the edges of the circle but doesn't run through the middle. All right, so here's a line segment right here, line segment CB. Remember, you could have also called that BC and been correct. So here's one. Some people might say line segment C to this point right here and kind of in the center of the circle. But remember, a chord has to have its endpoints on the edges of the circle. But I do see a chord CF or FC, whichever way you prefer to label it. Remember, it doesn't matter the order that you put the points in as long as they're the endpoints of the line segment. So writing line segment CF or writing line segment FC is the exact same thing. And then finally, I see chord FG. Remember, some people might think, well, what about DE? Is DE a chord? It meets the definition of a chord because it runs through because it has endpoints on the circle. But when it runs through the center of the circle, like DE is, then we give it a special name. Then we call it the diameter. So what is an angle? An angle is formed when two rays or line segments are connected at a single point that we call the vertex. All right, the difference in the direction of the two rays is what we call the angle measure. And we measure an angle in degrees. So what do I mean by vertex? We'll take a look at the diagram here. The points where the two line segments connect or touch right there, that's called the vertex of an angle. So where I'm drawing this blue line dot right now. All right, and the difference in direction of those two rays, a ray is just a part of a line that goes on forever in one direction, right, is the angle measure. So we have to have some way of talking about how big an angle is. And the closer these rays are together, the smaller the angle measure. And the more that we open them up or pull them apart, the bigger the angle measure is. So the one that's the most referred to, especially in architecture, is a 90-degree angle. So take a look at the protractor here. The two blue lines here form a 90-degree angle. It's just like how the floor meets the wall in your house. All right, we also call that a right angle. If I close this line down more, make it closer to the other line, then that's an angle less than 90. If I open it past that, then that's an angle larger than 90. When I open it up, this angle here all the way so that it would be a completely straight line, like I've depicted down here, then we have an angle that is 180 degrees. So let's talk about a central angle in reference to a circle. Well, a central angle is just an angle whose vertex is the center of the circle. So take a look at this angle. Angle APB. All right, notice that its center is P, which is the center of this circle, so we call it a central angle. When we label an angle, we do it by labeling the center point in the middle. So for example, I would refer to this angle APB as angle APB, and this little symbol here that I've written, that's just a symbol for an angle. I could also refer to it as angle BPA. Either way is correct. However, the P, that vertex, has to be in the middle, when you label a circle. So that's what we refer to as a central angle. An arc is the part of a circle connecting the 2 points on a circle. So here I've labeled a circle and I've shown you the arc. Here we can see the arc AB. And in geometry, the way that I would refer to that or label it or write it is AB, and I put this little arc symbol over it. So I refer to that as arc AB. Just like line segments, the order that you put the points in doesn't matter, as long as they're the endpoints of the arc. So I could also refer to this as arc BA. So let's find the measure of the following angle, COD. Well, we can see here that the intercepting arc for COD is arc CD, and it measures 58 degrees. Therefore, angle COD is also 58 degrees. How about angle BOA? So where's angle BOA on this diagram? Let me use a different color here. All right, so here's angle BOA. Well, they didn't give me the measure of the intercepting arc here. So let's see how we can figure out what the measure of angle BOA is. All right, so how can I figure out what angle BOA is? Well, take a look at diameter CA. It runs through the center of the circle, therefore it forms a half circle. So we just talked about that in a half circle there's 180 degrees. And we know what the measure of BOC is here, it's 32 degrees. So if this much of this straight line is 32 degrees, then how much more do we need to get to 180 degrees? That's what angle BOA is. So if I were to take 180 degrees and subtract away the 32 degrees that we already have for angle BOC, then what's left would have to be what angle BOA is. So let's go ahead and do that. All right, so we take 180 degrees because we know in this straight line here from C to A there's 180 degrees total, right? All across here is 180 degrees total. So to figure out just this part of it, I'm going to take 180 and subtract away the 32. All right, so that would be 148 degrees. All right, because 148 plus 32 is 180. So now let's talk about what the measure of angle DOA is. Again, it's the same principle. So notice that here's the straight line C to A. Angle COD is 58 degrees, so this entire angle across here has to measure 180 degrees. So to figure out what's left to find angle DOA, all I have to do is take 180 degrees and subtract 58. And whatever we're remaining, what's ever left, is what the measure of DOA must equal. All right, so we go ahead and do that, and you can do that on a calculator freehand, and I get 122 degrees. Let's talk about finding central angle measures based on the percentage. So take a look at this diagram down here. Suppose we want to find the central angle of each sector of the circle. Okay, so here we have a depiction of a circle, and we can see that this much of it is 40% of the circle. This sector here is 12% of the circle, and this sector here is 48% of the circle. So if I want to find their angle measure, right, if I want to find out how many degrees this 40% comprises, I basically have to find what 40% of 360 degrees is, because there's 360 degrees in this circle. All right, so there's two steps to this, solving this problem. One, you just change the percent into a decimal. So you can do that by dividing it by 100 or moving the decimal place 2 places to the left. All right, so for example, 40% would be 0.40. So after you change the percent into a decimal, the next step is just to multiply that decimal by 360 degrees, because there's 360 degrees in an entire circle. All right, so let's find out what the angle measure here, or the central angle is, this angle here, of the 40% sector. Well, all I do is I change 40% into a decimal, that's 0.40, and then I multiply it by 360 degrees to come up with an answer of 144 degrees. So this angle measure here, even though it's not labeled on the circle, is 144 degrees. All right, so that's the time at home. This magenta part represents the time at home. The purple part here, which comprises 12% of the circle, represents 43.2 degrees of the circle. We changed 12% to 0.12 because 12% is 0.12 as a decimal, and then we multiply it by 360 degrees. And then finally this blue sector here, which comprises 48% of the circle. I want to basically find out what 48% of 360 is, so I convert 48% to a decimal, which is 0.48, and then I multiply that by 360 degrees, and that equals 172.8 degrees. So clearly if I add all these degrees up here, because that's the entire circle, right, it should equal 360. So 144 plus 43.2 plus 172.8 is indeed 360 degrees. So take a moment to pause the video and see if you can find out what the central angles of each of these sectors are. All right, for sleep you should have got 111.6 degrees. You would have converted 31% to 0.31 as a decimal and multiplied that by 360. The sector of food comprises 9% of the circle. So what's the central angle? Well, it's like saying, what is 9% of 360? Well, then I change 9% to the decimal, 0.09, and I multiply it by 360, and I get 32.4 degrees. The work sector comprises 20% of the circle, and 20% of 360 is 72 degrees. The must-do sector comprises 25.2 degrees of the circle. Entertainment, the central angle here in entertainment, remember I'm talking about how many degrees is this? Well, if this sector is 18% of the circle, 18% of 360 is 64.8 degrees. And then finally, the other sector is the remaining 54 degrees. And clearly, if I add all these degrees up, I should end up at 360 degrees because there's 360 degrees in the entire circle. For your exit ticket, make sure you go to the course announcements, click on the questions Asynchronous Session 2, answer the questions, and submit the Google form.